to try not to electrocute anybody. Would be a good goal this semester. So it's a little bit tricky. You have these little kind of cams here that you push down, and it slides down, push up, lock that back in place. It's not that bad, but if, of course, if there's anything that seems to be running low or not quite functioning correctly, please inform me as soon as possible so that we can correct things. Safety when working in and around the acid copper bath here. This is a significantly more acidic bath than pickle. Significantly more. So we need to be extra super careful with that, which I would recommend. And this is just good general stuff to have anyway as you get into patinas and things like that. But just getting some good rubber gloves with patinas and all sorts of other stuff so you can get a pair for yourself and then have, to be extra safe just in case of any splashing and things like that. You know, a face shield from the polishing room never hurt anything. Please don't put any steel or any other sort of materials into the bath. We're just going to be working with copper and brass. Now, as far as actually setting this up, I know it's easy to get confused, like what's an anode and what's a cathode, and this is like chemistry class again and everything else. So this is the actual rectifier that controls the voltage and amperage going to the bath. And basically what's going to happen is we have the chemical bath here that's an acid. We have this copper plate here, which I'll just show you because it's important for you. See, it's blue because there's a lot of copper in suspension in the bath. And then we have this plate here that gets eaten away. So this is a sacrificial plate. So what happens is we're applying a full current that goes through here, so it attaches here, and then as the current is flowing to your piece, which is attached to this bar in the center here, it's stripping the copper off of this sacrificial plate and attaching it onto your plate. So that's kind of the basic sort of cycle or process that you have going there. What you run into is the surface area of that plate determines you need to have less surface area that you're plating onto. So that'll determine how many pieces you can put in there. So the tendency is, and that's why I split you guys into thirds, is to overload the bath, and then nothing's happening because you have too much surface area in there. So, and then what people do is then they start cranking this up really high because nothing's happening, and then you either blow fuses or you start getting real fast deposition, which makes those real sort of crumbly nodules and stuff like that. So you want to just check your surface area there. Try not to have too many pieces in there at once. We have a calendar here on the side that you guys can sign up for. So you can just first come, first serve. Here's our little calendars. You can sign up when you're going to be plating and things like that. To the best of my knowledge, this section will be the only section using electroforming. So there might be maybe an advanced student here or there coming in and using it, but I think as far as main demand, it's not like Metals 1 where we're sharing with a lot of other folks and stuff like that. So we have that calendar right there. I'm going off script, so I've got to get back. So the red wire or lead goes to your anode, which is your copper plate. And looky, right here it says positive anode, negative work. So work is your work, the piece, which is the center one, and the positive, or the anode, or the red, goes to that anode plate right there. So here's the leads, red and black. It's very simple. Just dial that off, put it on there, clamp it down, and then what I would recommend doing is getting a little piece of sandpaper or, actually sandpaper would be better than steel wool, and just kind of cleaning the contacts a little bit, because this whole environment is very acidic. Stuff gets funky in here. You can see like all this kind of, patination that's happening and everything else. So you want to just clean the contacts to make sure you get good contact. You have that on there. Here. Now again, we're pretending the ventilation is on. Right. And then that gets good contact right on your bar right there. You want to make sure that these aren't touching each other and that you don't short circuit that whole sort of circuit that's going through the bath. So that, now, this is like a live electrical contact. So this is why you guys are now getting into the intermediate level. You're getting into more sophisticated techniques. So like, you know, when it's on, don't touch this because it's live. Don't touch this. Don't touch that, you know. Don't go poking around because this is a live open current and it will shock you. So, so we have that. This is still off right here. We also have a bubbler, which any of you have fish. You might have that in your tank. And so we have that, and the tube should be tucked behind the anode plate there, and that just gets the whole solution sort of bubbling and moving around so that you get better plating there. So the first thing that you're going to do is you're going to do a 2-inch brass letter. I've done the letter T for obvious reasons. And then you're going to plate 4 different time periods on there just to sort of see what is happening and get a sense of how the nodules might be growing on there and how to build up your different layers and things like that. So this is an example of your first piece. So basically you just do a 2-inch, whatever letter you're thinking of doing. You can think about different fonts, you know, stuff like that. But basically a 2-inch brass letter and solder it onto a just a little wire hanger, because you need to make sure that it has good contact and both on this bar, and that it's long enough that it's submerged down into the bath. So I'll have these examples out, so you don't have to put a cute little shepherd's hook on the end of it. But I find that it's very useful. So this would be an example of the first part that you're going to do. Checking through my checklist here, I have the bubbler in there. The rheostat, which is this dial that goes up and down, is all the way off. The increase arrow going that way. So it's cranked all the way counterclockwise back that way. So we're ready, and we'll just pretend like there's a piece in there. So put the cover back on, put this back down. Okay. So we have the power strip here. The bubbler doesn't have an on-off switch, so you just have to plug the bubbler in. Like that. This is off. We go on. And that means that it's on, so then all these electrical connections and things are now live, so don't touch them or lick them or anything like that. And then my recommendation is generally keep it very low at 1 volt. I found for my sample with the wax it took about 8 hours. When you're starting, you just want to electroform 4 distinct time amounts, keeping records of your time, voltage, and amperage, engraving it on the back there. So we have 2 indicators here, voltage on the left, amperage on the right. It says it right there. And then you can just like dial it up and just keep it really low. See, like 1 volt, it may not even be registering on the amperage there. That's fine. It's working. The light's on, the voltage is, you see the dial sort of moving. That means it's on and everything's working, and you can just kind of try it out. Now, with masking it out, however you want to, as you plate for 1 hour or something like that, and then you come back and then you want to mask it out, you want to put something that's going to seal the surface, that's going to make it not electrically conductive. So you want to put, like, nail polish would probably be the easiest thing to stop out, you know, another area, and then plate for another area and stop another area out, and so on. Don't go grabbing. Turn the dial all the way down, just as a habit, and then off. So then once that's off, then it's all clear and you're fine. Be on the safe side. I'm always working with the rubber gloves anyway, which give you an extra level of protection from any kind of electrical shock, as well as from any of the acids of it. So the rubber gloves do double duty there. Okay, so that's general electroforming. I know it's not like, you know, we could stand here for an hour and have like a time-lapse video of what's going on. So your part B for your sample that you're doing, since I'm the teacher and the boss, I'm making you guys donate your sample. Sorry, you don't get to, you can make more than one if you want. But so this is an example of the sample. I'm hoping that they'll be wonderful, amazing, and inspirational, and then we could like mount them up on like a little board, like this little primer of like metalsmithing. So that's T is for torch. A couple things on that sample to notice as you're passing around that I didn't remove sort of my lead wire into it. That's something that you will be removing. And also one of my little torch knobs came off there. And so, yes, it's copper. You can solder it back together. Imagine that. So you should be building up about that thick